Okay, let's see if we can put this all together now. Sine of 135 degrees. What's its exact value? And so I think we're going to use a combination of both what quadrant it lies in and its reference angle and some of those types of ideas to figure out how we can be helpful here. So sine of 135 degrees. In that direction, its reference angle, if theta is this, its reference angle, theta prime, is 180 minus 45 or minus 35, which gives me 45 degrees. And so the sine of 135 degrees will have the same value as the sine of 45 degrees. However, we won't know yet what its sine is. So the sine of 45 degrees, do we remember the sine of 45? I have it down here, sine of 45 was root 2 over 2. So sine of 45 was root 2 over 2. And now we can look back at our quadrant positive scale to find out. We know that sine of 135 lies in the second quadrant. We know that in the second quadrant, all the signs are positive. So therefore we can say that the sine of 135 degrees equals the value of root 2 over 2, and it's positive. So that is the exact, what's the word we're supposed to learn? The exact value of a sine 135 degrees. That was kind of fun. Yeah. So let's look at another one. See if this one can stump us. I think I have 1, 2, 3, 4 examples. This is the second of the 4. So cosine of 4, the cosine of 4 pi over 3. And we want to find its exact value. So probably the easiest way to do that, it would be easy if it was already an acute angle, but it's not. So let's find its reference angle, which is basically helping us get its acute angle. So 4/3 pi, well, that looks like it's a little bit past pi. So 4/3, 1 pi plus another third. So that's my theta. The angle to its closest x-axis, which is my theta prime, is my reference angle. So that reference angle then is taking 4 pi thirds minus a pi from that. And so what is that? Subtract a pi. In order to subtract pi, I need to have common denominators, 3 over 3. So I'm left with 1/3. 1/3 pi. So this distance right here is pi, or not distance, but its angle, its reference angle is pi thirds. So if I can find the value of cosine of pi thirds, value of cosine pi thirds is over here. So the value of cosine is 1/2. What's its sine? And that's what I'll go back and look for. I know that it landed in the third quadrant. The third quadrant tells me that tangents and cotangents are the only ones that are positive. So all cosines in that quadrant are negative. So therefore, the exact value of cosine of 4 pi thirds equals negative 1/2. All right, next example. 2 more and we're done with this section, guys. You guys are doing great. All right, Lost it. Sorry, folks. Cotangent of negative pi thirds. Well, let's find its reference angle first. So there's theta, that's negative pi thirds. Its reference angle is that the positive angle closest to the x-axis, which in this case happens to be the exact same one, but a positive version. So my reference angle is positive pi thirds. So what was my value of a cotangent of pi thirds? I don't have that listed down on my grid down there, but that was one of the reciprocals of the other potential, of the other three that I had. And so I think that was 3 over 1, flip it over, root 3 over 3. So the cotangent of pi thirds is root 3 over 3. We don't know its sign yet, because this was only the value of the reference angle. To get the value of the original angle, we have to see that it was in the fourth quadrant. The fourth quadrant over here told me that cosines and secants were positive. Everything else was negative. So I know then that my value of cotangent of negative pi thirds is a negative root 3 over 3. All right, the last one, friends. All right, so let's work the problem. We work the problem and we solve enough problems, we eventually get to go home. And so this one, I'm adding one additional problem within the mix. And see if you guys can identify it. I mean, one, we know we have to find its reference, and then we need to figure out which quadrant it is in. But it looks like the tangent of 4 pi thirds, looks like we need to find its coterminal angle first, because that's more than one rotation around the circle. So I don't really know where it's at yet. So let's eliminate some pi's from it, or some full circumferences. So 4 pi thirds, that probably is a little mature, or premature to draw that out first. I want to take away 4 thirds pi. Let's take away 4 pi maybe. Let's take it away 2 circles or 2 rotations in the circle. To do that, I need to have common denominators. So 4 thirds, 4 pi is the same thing as, what is that, 12 thirds pi? Yeah. There I go. 12 thirds pi is the same thing as 2 rotations around the grid. So then my coterminal angle is 2 thirds pi. So let's evaluate and find the value of the tangent of 2 thirds pi. Is that what I want? Yeah, 2 thirds pi. All right, so 2 thirds pi tangent. So I have 1 pi right about there. There's 2 thirds pi. Theta prime is 1 third pi. So let's find the value of 1 third pi. the value of 1/3 pi, or the tangent of 1/3 pi, and I think that I have it over here on the grid. So tangent 1/3 is √3. So the value is √3. It's in the second column, or it's in the second quadrant, excuse me. The second quadrant tells me all sines and cosines are positive. All sines and cosecants are positive. Everything else is a negative. I'm concerned about tangents. Tangents in this quadrant are negative. So therefore my value of the tangent in that quadrant has to be negative. So the exact value of the tangent of 14 pi over 3, we had to do 3 things to solve the problem. One, we had to find its coterminal angle. Then we had to find its reference angle. Then we had to find its value of the reference angle. Then we had to determine which quadrant it was in so we can determine its positive or negativity. And so we found out it was negative. And so throughout this section, we kind of explored those 4 to 5 or 6 steps that we built upon to get to a problem such as this, that we're able to find exact values of very complex trigonometric identities and angles. So I hope you have fun working through this section. I hope these videos are helpful in some way, guys, as you just continue to work through that. So keep up the great work.